I didn't quite finish 16. I was just about there. If you just come from the previous video, h of 6 is less than h prime of 6, which is less than h double prime of 6, which makes the answer A. Got the answer is A on number 15, as you can see there. All right, 16. A little particle motion here. It says the particle moves along the x-axis with its position given, where A and B are constants and A is not B. For which of the following values of t is the particle at rest? All right, so the particle will be at rest with a zero velocity. Okay, so that means it's not necessarily a change in direction, but it has no velocity. It's moving neither right nor left at the given time. Okay, so let's write down this position function. Sometimes you see the variable s, sometimes you see the variable x, as you do on this one. All right, so taking a look right here. So we want to find our velocity. Our velocity function is simply the derivative of our position. Okay, so we'll do a little product rule here, or what's probably easier actually is just to do some algebra. This is t squared minus bt minus at plus ab. Okay, where a and b are constants. I'm going to try to actually write that legibly. All right, so taking the derivative with respect to t, where a and b are constants, we'll have 2t minus b minus a plus 0. Okay, if you think about those being constants. And again, you just have the knowledge here. You've studied, you're ready for the AP exam. So you know a particle's at rest when the velocity is 0. So we'll let our velocity be 0, which is this function. Okay, so let's read the question again. For which of the following values of t is it at rest? Okay, so just want to solve for t. So kind of add a and b over, right? And divide by 2. So a plus b over 2, right, is equal to t. Yeah, so b as in boy for that one. That one's pretty quick. 17. The figure above looks like another fundamental theorem of calculus. You should know the fundamental theorem of calculus. That's pretty important for the AP exam. If you don't know it, study it before before you take the test. Okay, so let me get this written down. So it gives you a graph of f. All right, the figure shows that if f of x is given, which of the following could be the graph of y equals g of x? Interesting. All right, so let's think about what g of x is right here. Okay, so we know that f prime of x is basically g of x. All right, remember we take the derivative, it takes this out, but you have to think also about these limits. You have 2 and x here. Okay, if I wrote that down correctly. Okay, so remember your fundamental theorem of calculus. And let's look at each of these answer choices. Okay, so which one could be g of x? Now, this is a linear function. This is f. So our claim is g of x is equivalent to f prime of x. That is the derivative of f of x. Well, the derivative of x, and remember, fundamental theorem of calculus, doesn't really matter where you start. That 2's not really significant. But what we have, again, is a constant function, the derivative of a constant function, a linear function, excuse me, getting ahead of myself. The derivative of a linear function is constant, right? We have some positive number right here. We don't know what it is. We don't have any hash marks, but we know it's positive. So we expect our slope to be some positive number, some constant positive number, which is a. B would be incorrect because it's a constant negative numbers below the x-axis. C would be incorrect. That's what we would expect if f were quadratic. D looks quadratic, or at least polynomial in nature. We don't know what happens over here, but we would expect that if f was cubic. And here's another sort of negative polynomial look. But the correct answer would be A there. I don't know how well I explained that, but again, long story short, know your fundamental theorem of calculus. The 2 here doesn't matter. You can make that 0, whatever. The derivative of this would essentially cancel out the integral, and you would insert the variable x into the variable t, which tells us that g basically is the slope of f, which has to be a positive constant. Okay. 18, we'll finish with 18 right here. For this video, I think we'll run out of time otherwise. We'll see if we can get through here. 18, given a limit. The limit as h approaches 0 of the natural log of 4 plus h minus the natural log of 4 divided by h. Okay. So now if you just simply plug 0 in there, you're going to get an indeterminate form. This will be natural log of 4 minus natural log of 4, which is 0. 0 over 0 is indeterminate. Indeterminate form, remember, tells you nothing. Doesn't tell you it's 0, doesn't tell you it's undefined, doesn't tell you it's 1. It's just is useless. This is essentially the definition of the derivative. If you'll remember, f prime of x by definition is the limit as h approaches 0 of f of x plus h minus f of x divided by h. So looking at it here, what this appears to be then would be wanting for an f of x being the natural log of x, and we're specifically looking for f prime of 4. It's what, again, just knowing the definition of the derivative. Because you can see natural log where f is and 4 where x is. So it's the derivative with the 4 in that position. Well, the derivative of natural log is 1 over x. So the derivative of natural log evaluated at 4 would be 1/4. Okay, let's see what we got here. So B for number 18. Know your definition of derivative.